students, welcome again to another lesson for maths. Today, the topic we're going to be looking at is simultaneous and linear equations. It's not a completely new topic. It's a topic we've covered before in class. However, now I want us to go over some revision questions with regards to how we answer questions relating to simultaneous linear equations. And of course, if you can recollect, we have, can anyone tell me how many different methods we can possibly use when solving linear simultaneous equations? Well, if you can recollect, we have the graphical method and the algebraic methods. And the two algebraic methods are, can you guess? The elimination method and the substitution method. So these are the different methods we're going to look at in these questions, and then go over the steps involved, show you how we solve related questions. All right? And if you're ready, let's begin. Okay. Now, like we normally do, the questions I have may not appear clearly on the projector screen. Do not worry. I want you to download the attachment along with the schedule for the lesson. You will see all the questions clearly there. So download the questions first. If you haven't already done that, I want you to pause the video, go and download the questions first, and you'll see the questions clearly. All right? So let's see the questions we have. Well, we started with some tables, and the tables read tables 14.5, there's table 14.5, and 14.6, there's table 14.6. They are incomplete tables of values for the equations y is equal to 3x minus 1, there is y is equal to 3x minus 1, and y is equal to 2 minus x. So that's the table for y is equal to 2 minus x. And you can also use these tables when answering questions 1, 2, and 3. So we're going to need these two tables in answering questions 1, 2, and 3. Okay? And it's very important for you to complete the table with the correct values. Because of course, if those values are incorrect, then your answers to questions 1, 2, and 3 will be incorrect. So you have to be very careful and make sure the table of values are, the table of value for 14.5 and 14.6 are indeed correct. Okay, so let's see. Question 1. We've asked to copy and complete tables 14.5 and 14.6. So the tables, obviously, as you can see, are incomplete. So we have to complete the tables by putting the values there, and right there. So let's see how we complete the tables. Okay, now we have the equation y is equal to 3x minus 1, and it's this equation we only need to complete this table. Alright? But let's see if indeed these values are correct. When x is minus 1, are we going to get this corresponding value of y? Using that equation, y is equal to 3x minus 1. So let's go. So when x is minus 2, so let's just quickly check. When x is minus 2, putting the value of minus 2 in that equation, let's see if we are going to get the corresponding value of y as minus 7. So when x is minus 2, and when you see x in that equation, it will be replaced with minus 2. Alright? And so there you go. And what do you do next? You open the brackets. When you open the brackets, what do you have? Y is minus 6 minus 1, yes? 3 times minus 2 gives you minus 6. And minus 6 minus 1 is minus 7. So there you go. Y is minus 7. So that is correct. That's correct for the first set of values. Now let's complete the two remaining values for that table. So next, when x is 0, is really easy. That is so easy. When x is 0, what do you have? When x is 0, put 0 anywhere you see x in that equation. And when you do that, of course you know anything you multiply by 0 cancels. You have y is equal to 0 minus 1. And 0 minus 1 gives you minus 1. Okay? So, when x is 0, y is minus 1. So, you put your minus 1 there. Y is minus 1. There you go. Next up, when x is plus 2, when x is plus 2, again, wherever you see x in the equation, you replace with 2 to get the corresponding value of y. And when you do that, 3 times 2 gives you 6. 6 minus 1 is 5. So when x is 2, y is 5. Exactly, y is 5. Okay, so that's the table, the first table complete. Now, we will follow the same steps in completing the second table, but this time we're going to be using this equation, y is equal to 2 minus x. Alright, so let's proceed. So moving on to the second table, where this time the equation we're going to be using is y is equal to 2 minus x. Again, let's just cross-check to be absolutely sure that these values are indeed correct. So when x is minus 2, let's see if the value of y will be indeed 4. Let's just have a quick check. So when x is minus 2, so anywhere you see x, you replace with minus 2. So when x is minus 2, y will be 2 minus x, which is going to be 2 minus 2. Now remember, when you open the brackets, minus times minus gives you plus. So you have y will be 2 plus 2. Of course, 2 plus 2 gives you 4. Okay? So when x is minus 2, y is 4. That is correct. So let's complete the 2 remaining entries for the table using the same equation, y is equal to 2 minus x. So this time, when x is 0, again, when x is 0, that's so easy. When x is 0, you have y will be 2 minus 0, and 2 minus 0 is simply 2. Exactly. So when x is 0, y is 2. And then finally, when x is 2, now sometimes I do advise that you pause the video and do this yourself. Okay? Challenge yourself. Give yourself that little push. Make sure you do these things, and then, once you're done, you can then continue playing the video and then be absolutely sure that your answers are right. And if your answers are indeed right, then that shows that you are following. It shows that you understand. Okay? So now, when x is plus 2, put the value of 2 anywhere you see x in the equation, and then you have 2 minus plus 2. Well, when you open brackets, minus times plus gives you minus, okay? And so you have y is equal to 2 minus 2, and 2 minus 2 is simply 0. Alright? So there's a table complete. Table 14.5 and table 14.6 complete. Okay, so you can see that's quite straightforward. It's not hard at all. I expect all of you, or I should say most of you, if not all of you, I expect you to be able to do this. It's really quite straightforward. Alright, so following from question number 1, let's move on to question number 2. Remember, we've been told to use that table, or the 2 tables, to answer questions 1, 2, and 3. We've just finished question 1, so moving on quickly to question number 2. Now, question number 2 reads, using a scale of 1 centimeter to 1 unit on both axes, draw the graphs of the lines y is equal to 3x minus 1 and y is equal to 2 minus x on the same set of axes. Alright, so I have your graph there with your x-axis and your y-axis. Now it's important for you to always stick to the scale you've been given. Now the scale we're given here says for every 1 centimeter, that's equivalent to 1 unit. Alright? So you assume that the width of a box on your graph is 1 centimeter. So that 1 centimeter is equivalent to 1 unit on the x-axis as well as on the y-axis, because it says both axes. So on the x and y-axis, you have the same 1 centimeter representing 1 unit. Alright? So this your graph with the origin right there, and remember you have the table of values. Now we're going to complete the table of values here very quickly. The table of values we got from question number 1, remember? So these are the values and the table is complete. So now that we have these table values, we will use these table values to now draw the graphs, or I should say, draw the lines for the two equations. That is, the line for the equation y is equal to 3x minus 1, and the line for the equation y is equal to 2 minus x. So let's see. Now, we have to use these values of x and y. That is, for every value of x, you use the corresponding value of y for both equations. But let's start with the first one. When y is 3x minus 1. Okay? Now, when x is minus 2, y is minus 7. When x is minus 2, hang on, yeah, of course, this we cannot mark on the graph. Can anyone see the reason why? When x is minus 2, y is minus 7. When x is minus 2, y is minus 7. That is way beyond the scope of this graph. So we may not be able to mark that point, but don't worry. Let's go to the next point. When x is 0, y is minus 1. When x is 0, y is minus 1, which is that point there. Okay? So we were able to mark that, but we couldn't mark that because the minus 7, on the vertical axis, you have a minus 4, so we cannot go beyond, and that's why we couldn't mark the minus 2. But don't worry, if you can mark 2 points, then 2 points are enough to draw the line. Okay? 2 points are enough to draw the line. Okay? 2 points are as wide apart from each other as possible. Okay? So next up, when x is 2, y is 5. When x is 2, y is 5. When x is 2, y is 5. That's going to be somewhere above. Now let's see. Okay. Now, of course, because again that goes beyond the graph, I decided to pick a point in between 0 and plus 2. Let's say 1. When x is 1, 3 times 1 is 3. 3 minus 1 is 2. So y will be 2. So when x is 1, y is to reach that point. Alright? And with the 2 points, we're able to draw a straight line passing through the 2 points. And there is a line for y is equal to 3x minus 1. Then remember, you don't forget to label the line. Don't forget to label the line, okay? Don't forget to label the line as shown. Right, next up, we need to draw the line for the equation y is equal to 2 minus x. Again, using that table of values. Okay, we start with when x is minus 2, y is 4. When x is minus 2, there you go, minus 2, y is 4. Right there. Okay? And when x is 0, y is 2. When x is 0, y is 2. Right there. Okay? And finally, when x is 2, y is 0. When x is 2, y is 0. It's going to be on the x-axis. Right there. So we have the 3 points, and there is our line. So the blue line, don't forget to put the label, the blue line will be for the equation y is equal to 2 minus x. And there you go. There you have it. So we're able to draw the graphs of the 2 lines. And you're done. Okay? We did this in class, you can still remember, a couple of months back. Okay, so this is just to help you refresh your memories. Okay, so that's that question number 2. Moving on quickly to question number 3. Still on the table of values, remember, you have to find the coordinates of the points where A, the line y is equal to 3x minus 1 cuts the 2 axes, that is the x-axis and the y-axis, and then B, where the line y is equal to 2 minus x cuts the 2 axes, again, where the second line cuts the x and y axis, and then finally for C, where the lines y is equal to 3x minus 1 and y is equal to 2 minus x intersect, that is where the 2 lines meet, alright, which therefore takes us to takes us to question number 2, where we now have to bring back the graph from question number 2. Alright, and I've done that here. So there's a graph from question number 2. So very quickly, we have the graph. Okay, and so let's answer the A part of the question. So the A part, where the line 3x minus 1, look at the line 3x minus 1, where it cuts the axes, the two axes, that is the x-axis, this line will cut the y-axis at that point, and it will cut the x-axis at that point. Alright? And so there you go. I've indicated 2 points with the arrows there, and the coordinates at those points are as shown. So the coordinates at that point, the x-coordinate is 0, and the y-coordinate is -1. And then over there, the x-coordinate is -1/3, and then the y-coordinate is 0 because it's sitting on the x-axis. Alright? So for the line y is equal to 3x minus 1, it cuts the x's, and the 2 points are indicated with the red arrows. So on the y-axis, this is the y-axis, it cuts the y-axis at that point, the coordinates 0, -1, and then it cuts the x-axis at that point, the coordinates 1/3 and 0. Okay, meaning here, at that point, the x-coordinate is 0, the y-coordinate is -1. At that point, the x-coordinate is 1/3, and the y-coordinate is 0. There you go for the red line. Now let's see where the line, the blue line, cuts the axes, the y-axis and the x-axis. Now for the blue line cuts the y-axis at that point and cuts the x-axis at that point. Let's see what the coordinates are. Now I'm going to indicate the 2 points with blue arrows this time. Okay, so at that point, when the blue line cuts the y-axis, the coordinates there are x is 0, y is 2, which is that. And so at that point, the coordinates are x is 2, and because it's sitting on the x-axis, y is 0. Okay? So there you go, the coordinates there to 0. So for the line, y is equal to 2 minus x, and this is answering the B part of the question now. When the line y is equal to 2 minus x cuts the two axes. Okay, so the line y is equal to 2 minus x, it cuts the axis at for the y-axis, that's the blue line. It cuts the y-axis at that point with the coordinate 0, 2, where the x-coordinate is 0 and the y-coordinate is 2. And then it cuts the x-axis at that point with coordinate 2, 0, where the x-coordinate is 2 and the y-coordinate is 0. There you go. Alright? And that answers the B part of the question. Let's move on to the C part. Where does the line y is equal to 3x, where does it meet with the line y is equal to 2 minus x? Where do the two lines intersect? The two lines intersect, and you can see that where the red line meets the blue line. The two lines meet at that point, and I've indicated that with the blue, with the black dot. What are the coordinates at that point? Now here are the coordinates at that point. The coordinates at that point is a fraction. Okay, but don't worry, if you actually drew a graph, you just pinpoint that particular point of intersection, or if you use the algebraic method, either the elimination method or the substitution method. Okay, so the coordinates at that point is that. So there you go. The line y is equal to 3x minus 1 and y is equal to 2 minus x, that is the blue and red lines, they intersect at this point with the coordinates 3 over 4 and 5 over 4. Meaning the x coordinate is 3 over 4 and the y coordinate is 5 over 4. Alright? And that's it, and we're done. Okay? Moving on quickly to number 4. Number 4 says, solve graphically the following pair of simultaneous equations. X plus 2y is equal to 3 and 2x plus y is equal to 0. So when you ask to solve graphically, again, it means you have to draw a graph. And before you can draw a graph, you will need a table of values. You will need a table of values. So there's a graph. Okay, but like I said, we'll start first of all by drawing the table of values. Now, you pick convenient points, okay? In this case, I've decided to use, for the value of x, I've decided to use -3, -1, 1, and 3, just for convenience. And then we find the corresponding value of y using that equation. x plus 2y is equal to 3. Now when you do that, this will be the values of x. Oh, sorry, the values of y you're going to get. Okay? This will be the corresponding values of y that you will get here. And I want you to check that. Okay? Check that. Alright, and then when you plot the points, when x is minus 3, y is 3. When x is minus 3, y is 3. When x is minus 1, y is 2. When x is minus 1, y is 2. It's going to be somewhere there. Let's see. Yeah? And then when x is 1, y is 1. When x is 1, y is also 1. Right there. Oh, sorry. Exactly. And then finally, when x is 3, y is also 0. Sorry, when x is 3, y is 0. When x is 3, y is 0. So that's going to sit on the x-axis, right there. Alright, now when you draw a straight line, that will be the line or like the graph or the equation x plus 2y is equal to 3. So don't forget to put the equation on the line. There you go. So there's a line for x plus 2y is equal to 3. Next up, we need to draw the line for the equation 2x plus y is equal to 0. Okay, again, you need the table of values for that as well. And then pick convenient points for x. In this case, I decided to use minus 2, minus 1, 1, and 2. And then we now find the corresponding values of y using that equation. 2x plus y is equal to 0. So for each of these values of x, you need to get the corresponding values of y. Alright, so there we go. Those are the corresponding values of y. And then with these, we now plot the points. So when x is minus 2, y is 4. I'm going to use blue dots and blue line here now. When x is minus 2, y is 4 up there. When x is minus 1, y is 2. When x is minus 1, y is 2. Right there. And moving on, when x is 1, y is minus 2. When x is 1, y is minus 2. And then finally, when x is 2, y is minus 4. And finally, there's the last point. And then with a ruler, you draw a straight line linking all the points together. And that is your line for the equation 2x plus y is equal to 0. Now, when you ask to solve graphically, essentially, once you've drawn your two lines and you can see where the two lines meet, at the point where the two lines meet, that will be the solution. So you need to find the coordinates of that point. Okay, so there's the point where two lines meet, and I'm indicating that with a black dot. You need to write down the coordinates of that point. So the point has got the coordinates, if you observe, minus 1 and 2. Exactly. So the coordinates at that point, we have minus 1 and 2. So there you go. The line x plus 2y is equal to 3, that's the red line. And the line 2x plus y is equal to 0. They intersect, that is, they meet each other at minus 1 and 2, meaning the x value is minus 1 and the y value is 2. So the solution will be x is equal to minus 1 and y is equal to 2. And you're done. Okay, question number 4. So far, so good. Okay, so let's quickly move on to question number 5 because of time. Question number 5 now. So we're through with the graphical method. Now I want to look at the algebraic method. Remember I told you we have two main algebraic methods. The substitution method and the elimination method. Alright? So we're going to concentrate on the algebraic methods now. And then let's look at question number 5. Question number 5, when asked to use substitution method. Now you have to be careful, and that's when it's important for you to really know how to use the two methods. If, like we're told in this question now, you're categorically told to use the substitution method. If you use the elimination method and get the answer right, you may not get full marks because you have been told quite clearly from start in the question to use substitution method, and so that's what you're expected to use. That is why it's important for you to really know how to use the two methods. Alright? So let's see. Now to the substitution method to solve this pair of simultaneous equations. You have 4x plus 3y is equal to minus 1 and 2x minus y is equal to 7. Alright? Now, if you've forgotten the steps, we'll go over together. But if you haven't, I'll suggest you give yourself a challenge. Give yourself a challenge. Right, 4x plus 3y is equal to minus 1. Let's take that, make that like equation 1. and then 2x minus y is equal to 7. Let's make that our equation number 2. Now, remember you're going to use substitute method. Because you recollect, I told you that you look for the variable x and y, because the two variables here are x and y, x and y. You look at the variable with a coefficient of 1 and make that the subject, okay? So, substitute method, that's what we told to use. Step 1, you look for a variable with a coefficient of 1 and then make that variable with a coefficient of 1 the subject of the formula. Now, of course, x has got a coefficient of 4 there, so you don't use that. Y has got a coefficient of 3, you don't use that from equation 1. In equation 2, x has got a coefficient of 2, you don't use that. But y has got a coefficient of 1. As a matter of fact, a coefficient of -1. So you use y from equation 1 and make it the subject of the formula. Alright? So from equation 2, you make y the subject of the formula. When you do, of course, it's negative here, make it positive by moving it. You move it to the right hand side, it becomes positive, and then you now move this 7 to the left hand side. So y will now be 2x minus 7, which is what you have there. Okay, next up. So now you substitute this value of y in equation 1. So anywhere you see y, you now substitute or you replace with 2x minus 7. So let's do that quickly. Okay, when you do that, you have in equation 1, 4x plus 3y is equal to -1. So the y there will now be replaced with the 2x minus 1. And then, what do you do next? Open the brackets. When you open the brackets and collect back terms, you have 4x plus. Now, 3 times 2x gives you 6x. And then 3 times minus 7 gives you minus 21. Alright? And then you collect back terms. 4x plus 6x gives you 10x. Now you move the minus 21 to the right hand side. So you have 21, it becomes plus actually. So you have 21 minus 1. Okay? And so you have 10x is equal to 20. And then to get x, you simply divide both sides by 10. Exactly. When you divide both sides by 10, you realize that x will be 2. So divide both sides by 10, and x will be 2. So now we have a value of x. And given this value of x, you get the corresponding value of y. Remember, you just put in there to get the corresponding value of y. So now, since y is equal to 2x minus 2x minus 7, remember, since y is 2x minus 7, so now that we have the value of x, we put this value of x in there to get the corresponding value of y. Alright? So, you have y. So you substitute the value of x, this value of x, into that equation to get the corresponding value of y. Okay? So when you do that, so you have y now equal to 2x. The x will now be replaced with that 2, which is its value, and then you subtract 7. 2 times 2 gives you 4, minus 7. So y will now be equal to minus 3. When you subtract 7 from 4, get minus 3. So now we're done. But then, you need to check your answers by substituting this value of x and y into the original equation to be absolutely sure. Okay, so when x is 2, y is minus 3. When x is 2, 4 times 2 gives you 8, plus y is minus 3. 3 times minus 3 gives you minus 9. Aha. And so we have plus times minus gives you minus. So 8 minus 9 gives you minus 1. So it's correct in the first equation. Now let's just check the second equation. Let's hope it's going to be correct as well. When x is 2, 2 times 2 gives you 4, minus y. Y is minus 3. Minus 3. Aha. Minus times minus gives you plus 4 plus 3 gives you 7. And so undoubtedly, these are the values of x and y. X is 2 and y is minus 3. And so clearly you have those steps that you follow when you're using the substitution method in solving any given linear simultaneous equations. Okay? Alright, we move on to question number 6. Okay? So that's question number 6. You will have to use the elimination method. Aha! Substitution was the previous example in question number 5. Now you're going to have to use the elimination method to solve the given pair of simultaneous equations. 2x and 7y is equal to 3, and 2x minus y is equal to 3. So now let's see how we are going to use the elimination method this time around. Okay? First thing first, you write down the equations. 2x plus 7y is equal to 3, equation 1. And then 2x minus y is equal to 3, equation number 2. Right, so question number 6, we're not to use elimination method this time around. And there you go, you've got the first equation, 2x plus 7y is equal to 3. And then the second equation, 2x minus y is equal to 3. Now remember, when you use the elimination method, can you recollect the steps we follow? Well, don't worry if you cannot, we go over, right? That's the essence of going over the questions, just to help you recollect the steps involved. Alright? So with regards to the elimination method, when the coefficient is the same, so you look for the same coefficient of the unknown in both equations. Now, look at the coefficient of x there, it's 2. The coefficient of x there is also 2, so the coefficient is the same, that's fine. So you stick with x in this case. Now, the coefficient of y in equation 1 is 7. The coefficient of y in equation 2 is minus 1. The coefficients are not the same. So ignore y for now. Stick to x with the same coefficient. So that's how you proceed with elimination method. You look for the variable with the same coefficient in equation 1 and 2. So when the coefficient is the same, a good start, a good step forward. We now proceed to the next step. What do you do next? You now so I've highlighted the coefficient that is saved there in green for you to see clearly. So what you do next? You look at the sign. Look at the sign. So what's the sign next to there? Can anyone guess? Remember, like I told you, when the sign is not indicated, it's automatically taken to be what sign? Positive or negative? Yes, positive. When the sign is not shown, it's automatically taken to be positive. So the sign is not shown there, so it means it's positive. And then in the second equation, the sign is also not shown, so it's also positive. Exactly. It's positive. So there you go. The sign is both positive. Okay? So, and remember our SSS and DSA. SSS, which is short for same sign, subtract, and DSA, which is short for different signs you add. But in this case, the signs are the same. Same sign, you subtract. Exactly. So in this case, because the signs are the same, we are going to subtract. Let's see how we do that. We're going to subtract. So again, we write down our equations. So I'm rewriting the equations very clearly now, but this time we're not going to subtract. We'll subtract, and then we subtract. Remember, 2x minus x. 0. Exactly. So the x is eliminated. The x is eliminated. And the next up, you have 7y minus y. And remember, minus times minus gives you plus. So 7y plus y gives you 8y. Right. So you have 8y, and then 3 minus 3. Aha. 3 minus 3 is exactly 0. 3 minus 3 is 0. And if 8y is equal to 0, therefore y is 0. Exactly. Y is 0. So there you go. That's the value of y. And now that we have the value of y, we need to find the corresponding value of x. Okay? So you put this value of y in equation 2. Now the choice is yours. Okay? The choice is yours. But my advice will always be that you put the value of x or the value of y or the value which you've got into the equation with the smaller coefficient. Okay? So we're looking for, we have y, we're looking for x. So you put it in equation 1, or sorry, in equation 2, because here y has got equation 1, which is smaller. If you put it there with equation 7 and you multiply, it's going to make it bigger. So that's why we prefer a variable with a smaller coefficient, because when you multiply, the value will be smaller. Okay? So when you put this value of y in equation 2 with a small coefficient, let's see what we have. So now we will replace the y with its value, which is 0, which is basically nothing now. So you have 2x minus 0 is equal to 3 in equation 2. And so 2x minus 0 is equal to 3. That's simply 2x is equal to 3. If 2x is equal to 3, to get x, what do? You divide both sides by 2. Right. When you divide both sides by 2, x is simply 3 over 2. Or if you like, x is 1.5. Remember, well, if you can't see very clearly, when you divide both sides by 2, this 2 goes in that. So x is 3 over 2. Or if you like, 1.5. So there we have it. But then remember, it's important to always check your values of x and y by putting them in the given Simultaneous equation. So as a quick check, just to be absolutely sure, it's a necessary final step. Just to be absolutely sure that these values are indeed the correct values. So let's put these values of x and y into the equation, just to be absolutely sure that they are indeed correct. So when x is 3 over 2, y is 0. Well, y is 0, when y is 0, that basically goes. When y is 0, that goes. X is 3 over 2. So what is 2 times 3 over 2? This 2. What comes with that? And you have 3. Which is that 3? So it's correct for equation number 1. Let's just do a quick check as well for equation number 2. Y is 0. That's easy. Means that bit goes. No problem at all. But x is 3 over 2. So you have 2 times 3 over 2. 2 times 3 over 2. Again, this 2 becomes that 2. And you're left with 3. So it's indeed correct for equation number 2. So undoubtedly, for the solution of this given pair of Simultaneous equations using elimination method, x is 3 over 2 and y is 0. Or if you prefer, you can also write that x is 1.5, which is also still perfectly acceptable. So far, so good. So I'm sure you all can now see how we use the substitution method and the elimination method in solving any given pair of linear simultaneous equations. Let's move on to question number 7. Okay, and I'm afraid this is the last question we're able to go over. The remaining questions 8, 9, and 10 I'll give you to solve as homework, and I want to send you your answers. Drop your answers in my inbox. Question number 7. Aha! Now this is a word problem. A word problem leading to simultaneous equations. Let's see. It says the sum of two numbers is 14. And their difference is 8. Find the two numbers. So how do we proceed? Okay. Well, of course, so we don't know what the two numbers are. Let's just use A and B, or if you like x and y. Okay. So using the first statement, the sum of two numbers is 14. Sum meaning addition. We don't know what the two numbers are. Let's do them by the letters x and y. So x plus y is 14. That is, the sum of two numbers is 14. And the difference is 8. So the second equation is going to be x minus y is equal to, can you guess? 8. That's right. So that was the second equation. Alright? So now I have a pair of simultaneous equations. And again, the choice is yours here. You haven't been told to use either substitution method or elimination method. The choice is yours. Okay? I've decided to use the elimination method. Okay? So when the question is the same, look at the signs. Question is the same. Now, of course, the choice is yours. You can either go for x and y because they have the same question. But in this case, I've decided to go for y to demonstrate the fact that this time the coefficients are different. Okay? Remember our mnemonics? SSS and DSA. SSS, same sign, subtract. But here we have the signs different. Different signs will add. So we're going to add now. We're going to add now because the signs are different. We will add. So let's see. When you add them together, of course, x plus x, that gives you 2x. And then y goes, and then 14 plus 8 is 22. 2x is equal to 22, therefore x value is 11. And I'm sure you all can see that. So we have to put this value of x in equation 1 to get the corresponding value of y. That's equation 1. So anywhere you see x, you replace with 11. And so you have y will be 14 minus 11, then y is 3. Okay? So the two numbers are 11 and 3. And of course you can check. 11 plus 3 gives you 14. 11 minus 3 gives you 8. And we're done. Okay? Now, I'm afraid we don't have much time. I would suggest, please, try the remaining questions. Questions 8, 9, and 10. And send the answers to my inbox. I'll be waiting for them. Alright? So, we'll stop for now. I shall see you again some other time. Stay safe. Bye.